This next algorithm is called Dijkstra's algorithm or shortest path algorithm, and it's different to Prim's and Kruskal's algorithm in that it doesn't find the minimum spanning tree, it finds the shortest path from one node to another through a network. It was invented by this guy, Mr. Dijkstra. And there's all sorts of real life applications to this. Anything where you find the shortest distance from one point to another. So transportation networks, sat navs and things, telephone networks, internet, satellites, all that kind of stuff use variations of this algorithm. The steps are outlined in your pack here, but I'm not going to go through them. I'm going to use an example for this to make sense. Before we get into it, your algorithm will look something like this. You'll be provided with a diagram like this in your exam for you to fill in the boxes. You must fill in these boxes accurately with exactly the right values in exactly the right order to get full marks for this. You'll have a key on your question as well, telling you what goes in each of the boxes. So your top left box will have a letter in, that's what vertex is. Then along the top, you'll have an order of permanent labelings. This is the order that you have added this into your algorithm. A permanent label is the shortest distance of your node to the start node. And along the bottom, we'll call these temporary labels or working values. These need to be put in the correct order, the correct values as you go along. But these are the important part of the algorithm. So to start off a Dijkstra's algorithm, to find the shortest path from S to T, you always label up your first node with a 1. That's the first node that you've added into your algorithm, and a 0 for your permanent label. So obviously it's a distance of 0 from itself. Look at every node connected up to this start node. So that's A, B, and C, the direct connections. And in the temporary labels underneath, you're going to put in the distance of those nodes from S. So you're going to put 5 under A, 6 under B, and 2 under C. Select the shortest of those, which is C, 2, and that becomes permanently labeled now. So you're going to label up C with a number 2. It's the second node that you've added into your algorithm. And this is a distance of 2 from S as well. So that working label value now becomes a permanent label. Repeat the process with C. So look at everything directly labeled, linked up to C. So S is directly linked up, but that's permanently labeled, so we don't need to do anything with that. B is directly linked to C. Now, in the working values under here, we're now going to do this 2 underneath, or permanently labeled up in C, add this 2 on the arc to give us 4. This is the shortest distance that we can have from B to S. Now that's via C. So we need to replace the 6 with a 4. You can cross it out, or you can just leave it, but please don't rub it out or don't completely obliterate it, don't scribble it out. It needs to still be visible in there. So we replace this 6 with this 4. We also need to label up T. So you've got the 2 from C, add on the 12, that's a distance of 14, goes into the temporary label under 14, under T. Look at the ones that have not been permanently labeled up yet. So that's A, B, and T, and choose the smallest of those, which is B. So we're going to label that up with the number 3. That's the third one we're adding on, and it's now got a permanent label of 4 in there. Look at the ones directly connected up to B. So we don't need to worry about S and C. They've already been permanently labeled. D and T are directly connected as well. So in D, we've got the 4 from the permanent label in B. Add on the 4, which gives us 8. And we've got the 4, add 8 gives us 12. For T, we can replace that 14 with this 12. Out of the 3 left that haven't been permanently labeled up yet, A is the smallest of these, so this will be the next one added on. So this is labeled up number 4 and a permanent label of 5. The only one directly connected up to A that hasn't been permanently labeled yet is D, so that's 5 add 4 gives you 9. Now this is bigger than the 8 already underneath the D, so you don't need to write this in. You only need to replace a working value if it's smaller than the previous one. This 9 is bigger, so you don't need to put this in. You can put it in and cross it out, but you don't need to. Out of the 2 left, D is the smallest, so we label that up with number 5 and a permanent label of 8. Look at the ones directly connected up to D. So A and B are already dealt with, but we've got 8 plus 3 gives us 11, which now goes underneath T because it's the smallest. That's smaller than 12. T is the only one left to label up, so I'll label that up with the number 6 and a permanent value of 11. This value of 11 is the shortest distance that you can have from S to T. To finish this algorithm off, you need to work out what the shortest path is. And to do this, you work backwards through the algorithm. So you start off at T and you look for the nodes where the difference between the permanent labels is the same as the arc length. So for the first one, T to D is 11 minus 3. 11 minus 8 gives us a length of 3. So that one is correct. Then it's D to B because 8 minus 4 is 4. Then it's B to C because 4 minus 2 is 2. And then it's C to S. Matches up there. Make sure you write out the shortest path in the correct order. So that's S, C, B, D, T. And that's got a total length of 11. Now you're paying close attention. You must have everything written correctly in all of these boxes to get full marks on a question like this. So first off, it asks you to find the shortest walking time between A and G. Make sure you read carefully because usually it is the leftmost to the rightmost, but sometimes it's not. So make sure you read carefully. First off, label up A with a 1 and a 0. First box is always labeled up with a 1 and a 0. Then everything attached to A, put something in the working values. So B, D, and C, put 4, 7, and 3 in respectively. Choose the smallest out of those to label up second. So C is getting labeled up with a 2 and a 3 in that permanent label in there. Look at the 2 connected up to C that are not being labeled up yet. So we've got D and E. So a temporary label goes in D of 6 to replace that 7. So we add that 3. And a temporary label of 8 underneath the E from the 3 plus 5. Smallest out of those 3 go back to B. B is number 4. So that gets labeled up third. And a permanent label of 4 goes in there. Look at F and D, both connect up to B now. So you can replace the 6 in D with a 5. The 4 add the 1. And you've got 4 add 4 gives you 8 into F. Now the 3 not labelled up yet, choose the smallest, which now is D. So D is number 4 with a permanent label of 5. 3 of these connected up to D that haven't been labelled up yet. So you've got 5 add 2 gives you 7 that you can put under the F. 5 add 2 gives you another 7 that you can put under the E. And you've got 5 add 7 gives you 12, which goes in G. You've got a choice here. F and E both have number 7 in. So it doesn't matter which way around you put these. So I would just go alphabetical. Well, it doesn't really matter. So we'll label up E 5th with a permanent label of 7. We can replace the 12 underneath G now with a 9. So 7 add 2 gives you a 9 in there. Smallest out of those 2 is F and G. So F is a 7, so that's the 6th one. You've got 7 add 4 gives you 11, which we don't need to replace the 9 by. If you'd chosen those the other way around, you would need to have the 11 in here and then replace it with the 9. But that way around you don't, yes.
I did E as 5 and F 6.
Yeah.
I still put the 11 in, but I shouldn't put the 11 in.
Did you put it after the 9?
Yeah, no.
Right, it should have gone after the 9 because in the order that you've done the algorithm, it would have come after. That gets labeled up as the 7th. You've got a 9 there. So the minimum walking time, so the shortest walking time from A to G is 9. We want to, it doesn't specifically say, but you should find the path as well. So you'll go from G to E matches up with that 9 minus 7 gives you 2. You've got E to D then with the 5, and then you go in by a B. So it should be A, B, D, E, G. For your path, just list the nodes in the order that you've gone through them. It should be linked. Okay, but everything in those boxes needs to be the same, apart from if you did 6 and 5 instead, you could have an extra 11 in there. Everything else needs to be the same. State the minimum walking time from A to E. It's literally just this permanent label here. It's just 7. You can write that down. That's what that number is. So if you're happy and you want to have a go at this yourself, absolutely do that. So you've got the question on one page and then you've got the answer booklet on the other page, which is a little bit annoying.
We're doing this 2019.
Yeah.
Oh yeah, it's gonna.
So we're only looking at part A on this one. I haven't actually thought how to do this. So we're only looking at part A. Use the Dijkstra algorithm to find x and y, it says. Then the question, it says, weights represent different distance. Weights on C, E, and GH are x because x and y. And we know that x plus y is between 7 and 21 each at some point. Important bit of information, it says there are 3 paths from A to H that have the same minimum length. So let's do Dijkstra's algorithm and see where this is going to take. So you get given this in the exam. It gives you a little key down here telling you what everything is. So vertex, order of labeling, final value, working values. Working values is another way of saying temporary labels. We're going from A to H. So in A, label that up with a 1 and a 0. All the nodes connected up to A, put something in their temporary values. So we've got 10 in B, 17 in C, and 9 in D. Shortest out of those 3 is the 9. So label D with a number 2 and a final value of 9. Next, look at everything connected up to D. So we've got 9 add 7 gives me 16. So I can replace the 17 in the C with 16. And I've got 9 add 12 gives me 21 G. Just those 2 to look at. Smallest out of these 3 working labels is B. So label that up permanently with a number 3. And this has got a final value of 10. Look at these 2, C and E, that are connected up to B now. So 10 add 5 gives me 15. So I can replace the 16 with a 15. And 10 add 25 gives me 35. That goes under. Here's where I wish my writing was smaller. So I'm going to start adding in X and Y's and stuff. Smallest out of these 3. So we've got C is 15. So that's the smallest. That's labeled up with a number 4 and a permanent label of 15. Looking at everything connected to C now. So we've got 15 add 3 gives me 18 underneath G. Got 15 add 7 gives me 22 underneath F. And underneath E, I've got 15 add X plus Y. And you need to decide if that is less than 35 or not. Is it less than 35? How do you know? Good. In the question, it tells you that X plus Y is less than 20. Which means it must be less than 35. So we've got 15 plus X plus 1. Question now is, which is the smallest out of those? Obviously 18 is less than 22, but is 18 smaller than 15 plus X plus Y? It is. Why is it?
X plus Y is greater.
Yeah, if X plus Y is bigger than 7, this whole thing's bigger than 22, isn't it? So we know this is the biggest out of these 3, actually. So 18 we're going to label up with the number 5 and 18 in there. We've got 18 add 2 gives me 20, so I can replace this 22 in here with a 20.
Joe, which is the part you got to 18?
This 15 plus 3 here.
Oh yeah, A, B, C. That's what I said.
And under H, we've got 18 plus 3x plus y. That's the first one in there. We'll put that in. Looking at all of these now, which is the smallest. So I'm looking between really 15 plus x plus y and 20. 20 is the smallest of this because we established that this one is bigger than 22. He's bigger than 22. So F number 6, put a 20 in there. Consider the ones connected up to this. So we could have 20 plus 16 gives you 36, but we don't need to put that in there. We already knew that this was less than 35, didn't we? So we don't need to put that 36 in there, but you must at least think about it, at least consider it. You've got 20 plus 13 gives you 33, which I am going to put in here, but I'm not going to get rid of the other one. The reason is in the question. Remember, it said there are 3 paths that are the same length from A to H. So that, I think that's spot. Next one we're going to label up is E. So that's number 7. This is 15 plus X plus Y. Squeeze that in there. Add on the 9 gives me 24 plus X plus Y. So I've got 3 different options to get into H. I'm going to label H up with the number 8, and I'm going to label it up with the value that 30. Because I know those 3 options that I've put in there are all the same, all equal to those. This gives you simultaneous equations which you can solve for X and Y. So we've got 18 plus 3X plus Y equals 33. And we've also got 24 plus X plus Y equals 33. So equation 1 is 3X plus Y equals 15 if I minus the 18 across, and we've got X plus Y equals 9. Solve those simultaneously. You can solve them in your calculator, that's fine. Guys, shh. So you get X is 3 and Y is 6.